Hi there, we're nearly there. It's question 8. This looks like a differential equations question, so let's have a look. So we're asked to show that the transformation x is e to the u transforms a differential equation given by this into this differential equation. So that's first thing, 6 marks. It's a show that question, so we need to make sure we're proving what we're doing rather than just doing it. So we're told that x is e to the u, so this is a typical transformation to do to solve this type of equation. It's called an Euler equation. So if I differentiate with respect to u, then I get e to the u, which is equal to x. So that's the first thing that's quite useful. We then need to work out the first and second order derivative with respect to u. Now it's good to remember to do that because it'll make the working a bit easier. So if I want to work out dy du, I can just apply the chain rule, and it's the same as dy dx times dx by du. Dx by du just worked out as x, so this is x dy dx. So dy du is equal to x dy dx. It'll be a useful one. And then we want to work out the second order derivative d2y du squared, which obviously is the derivative with respect to u of dy du. So I can just substitute that in. So I've got x dy dx. Now it's a little bit annoying here because I'm differentiating with respect to u, and everything in this bracket has got x terms. I'd really be able to just differentiate that with respect to x, which I can do. So just to make this make a bit more sense, if I call this f, then I am looking at df by du. And I can quite happily write that as df by dx times dx by du, again using the chain rule. So df by dx is exactly what we want to do, derivative with respect to x of all that stuff. And dx by du, when we've worked it out right at the start, it's just x. So I'm just going to put an x in front. Then I'm going to do product rule to differentiate what we've got here. So differentiate the x first, and I'm just left with dy dx. Plus, I'm going to keep the x there, differentiate the second term, that is d2y dx squared. So I've got x dy dx plus x squared d2y dx squared, and that is what d2y du squared is equal to. Okay, so sometimes people remember these formulae, but obviously here it's a show that question, so we need to show where they come from. And the trick really is just using the chain rule here. Some people could teach you that, okay, d du, you can rewrite this slightly, although it might appear a bit of a monstrosity. This is the same as doing dx by du times d by dx. You think of the dx's as cancelling, although they really don't. Okay, it's a piece of notation. That's the reason why the notation is really good, because it can help you to remember formulae quite easy by having informal ways of thinking about them. So we now need to apply this to our equation. So we've got x, let's do it over the other page. So I've got to add x squared d2y dx squared plus something x dy dx plus something y equals something else, because it's an Euler equation. So 3x and then minus 8y, 3x minus 8y, and that was equal to 4 ln x. So if we do this transformation, it's worth just pointing out what is 4 ln x. Well, 4 ln of e to the u, so that's just going to be 4u. Probably made some sort of pun there. And then we've got x squared dy dx. So x squared d2y dx squared. And I want to use this here to get my second derivative, but I need an x dy dx. So I'm going to take out one of them. So I'm going to split up this term into x dy dx and then 2x dy dx. So let's split up that term, because then this bit here is my second derivative with respect to u. So this then becomes d2u dx squared plus 2x dy dx, and that is just 2 dy du. Sorry, this should say dy du squared. Sorry. And then that's minus 8y is equal to 4u, which is what we've been asked to show. And then part B is to determine the general solution expressing y as a function of u. So part B, so we've got a second order differential equation. Let's write our auxiliary equation. So first of all, we're going to solve the homogeneous one, where everything is going to be equal to 0. So we need our auxiliary equation. So I'm going to have m squared plus 2m minus 8 equals 0, which is just this equation, but the order of the derivative is what m is. And we're setting equal to 0 because we're solving the homogeneous equation first. And then we're going to need to write this to the brackets. So m plus 4, m minus 2. So yeah, our values for m. So m is equal to minus 4 and plus 2. Or plus 2. So then our general solution becomes y is equal to ae to the minus 4u plus be to the 2u. And we can't find the values of the constants because we're not given any conditions. So we also need to then look at our right hand side to solve the inhomogeneous equation. So because it's a linear term, we need to guess a linear term. So I'm going to say y is equal to au plus b. If I differentiate that, so I'm just going to get a, and if I double differentiate that, I'm going to get 0. And then I want to pop this into this equation here. So 0 plus 2 dy dx and dy du was a, and then add minus 8 lots of y, 8u plus b. And that's going to equal 4 times u. So then I'm going to have minus 8a times u plus 2a minus 8b is going to equal 4u plus 0. You don't have to write the plus 0. But then we're going to equate coefficients. So I can say that minus 8a has to equal 4. And 2a minus 8b has to equal 0. So that's going to equal that. Coefficient of u has to be equal like that. So a is going to be minus a half. And then I'm going to get 2a is equal to 8b. So b is going to be 2/8 or a quarter of a. And then a was minus half, that's minus an eighth. Just minus an eighth. So that means my particular solution that we've just worked out is minus a half u minus an eighth. So my overall solution to my inhomogeneous equation is going to be y is ae to the minus 4u plus be to the 2u minus a half u minus an eighth. So that's my full general solution to the inhomogeneous equation. And then we're asked to find the general solution of the differential equation in the first part. So we want to transform it into everything in terms of x rather than u. So remembering that x is e to the u. So I should rearrange that for u is going to be ln x. So y is ae to the minus 4. Now u is ln x, so actually this is going to be ln of x to the 4 plus be 2, so that's going to be ln x to the power 2. So I should have minus 4 up there. And then I've got minus a half, u is ln x, minus an eighth. So this is going to be minus 8x to the minus 4 plus bx squared minus a half ln x minus an eighth. And if you were to check that was the answer, you could differentiate it twice and substitute it back in, but I don't think you'd have the time for that, especially for a single mark. Yeah, but quite a nice standard question, but important one in terms of knowing how to use those formulae to then rewrite your differential equation, and then how do you solve a second order differential equation, and then just a little substitution at the end to get back your result. Hope you found that helpful. Thank you. Take care.